Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about analysis of multiple loops. So let's get started. In previous video we have seen different types of loop and we have also seen how to find the order of growth of those loops. Now let's take the challenge to next level and see what happens when we have a multiple loops subsequently or we have multiple loops nested in each other. Okay. So let's start with the first example. So in this example, we have a function. This function takes input n, and inside this function we have three loops. We have seen this type of loops in first video, this type of loop also, and this type of loop also. So if I ask you what is the order of growth of this loop, it's going to be clearly theta n, because we are running a loop from 0 to n. This loop we are running 1 to n, and each iteration we are multiplying I by 2. So the time complexity or the order of growth of this loop is going to be theta of log n. And if I talk about this loop, we are simply running a loop from 1 to 100, and we are doing constant amount of work inside this loop. So as we are running this loop from 1 to 100, it means the order of growth of this loop is going to be theta n. So whenever we have this type of scenario where we are running loop one after the another, and this type of arrangement we call it a subsequent loop. And whenever we see this type of arrangement, we simply add the time complexity or the order of growth of those loops. So when we add all the three order of growth, we get theta of n plus theta of log n plus theta of 1. And in asymptotic analysis, we generally not interested in lower order term. So here in this case, log of n and 1 is the lower order of term. So let's ignore this. So we get the overall time complexity or order of growth is going to be theta n. So far so clear. Alright, let's move on to next example. In previous example we have a subsequent loop. In this example we have nested loops. So what's the order of growth of this for loop is going to be? We are simply running a loop from 0 to n, and we are increasing I in each iteration by 1. So it's clearly theta n because it is a linear order of growth. And in this loop we have again one nested loop, and in this loop we are running this loop from j equal to 1 to n, and in each iteration we are multiplying j by 2. So the order of growth of this loop is going to be theta of log n. And we have seen both the type of loop in our previous video. So whenever we have this nested arrangement, we simply multiply the order of growth. So here if we multiply theta n by theta log n, we get theta n log n. So the order of growth of this nested loop is going to be theta n log n. Great. So let's move on to the next example. In this example, we are using subsequent plus nested loop, and we call it mixed loop. So in mixed loop, we have combination of subsequent and nested loops. So let's see, we have a function, it takes n as an input, and on top of it, and at the first line we have nested loops, and the order of growth of this loop is going to be theta of n log n. And after this loop, we again have a nested loop, but this time the order of growth of this loop is going to be n square. Why? Because for each I we are running j from 1 to n, right? That's why the order of growth of this loop is n square. Again we have a subsequent loop, so we add both the order of growth. So after adding order of growth, we get n log n, theta n log n plus theta n square. So after ignoring the lower order term, we get n square, because n square is the higher growing term here. That's why we just ignore the n log n. Alright, let's see one more different example. And in this example, our function is taking two inputs. In all the previous example, we were only taking one input, but in this example, we are taking two inputs. So our loops are completely depends on input. So this loop is depend on n, and our below this loop is depends on m. So if I talk about this loop, the order of growth of this loop is going to be theta of n log n, because we are running for each I from 0 to n, we are running this loop from j to n. That's why the order of growth of this loop is n log n. And if we talk about this loop, the order of growth of this loop is going to be theta m square. Look at this carefully, okay? Here we are using m and here we are using n. So for each I equal to 0 to m, we are running j. That's why the order of growth of this loop is m square. The first for loop depends on input n and second for loop depends on input m. So do not get confused. So both the loops are subsequent. It is returned one after another. So let's add the time complexity. So it becomes, after adding the time complexity, it becomes theta n log n plus theta m square. So the overall order of growth of this function is going to be theta of n log n plus m square. So I hope after watching this video you have a clear understanding of how to get or how to find the order of growth of nested and subsequent loop. Thanks for watching. See you in the next video.